meeting of the current session. The second one, we've been back in the Arcadis office after our sojourn into the Network Rail St Street facility. Welcome to everybody who's joined online and to everybody in the room. Just a wee bit of housekeeping for people who are here in person. So there's toilets are in the lift area, in between the lifts. If you need water, it's quite warm in here, and the aircon's probably a wee bit noisy. There's a zip tap in the kitchen, the glasses here, and a glass of water. There's no fire drill planned, so the alarm drill is for real. If you just come out this room, follow the fire exit signs, it'll take you down the stairs, and there's an assembly point just at the corner of Douglas Street and St Vincent Lane. There's also a defib in the breakout area as well. Jonathan, I don't know if you want to go over any upcoming events or
just AGM next week. It's online. As many people can get at it as possible. Obviously, the main thing that the committee does and the AGM does is really just look at potential speakers and whatnot, etc. So if anyone can get along, it'd be very much appreciated.
Yeah, it's next week, isn't it? Yeah. Well, so our meeting tonight, we've got two speakers here. So we've got Conor Fitzpatrick and Ryan McCoy from Babcock. Both Conor and Ryan are senior project engineers. Conor on the permanent way side, and Ryan on the civil side. And they're here to talk to us about Belfast Central Station delivery, focusing on their respective disciplines. Guys, in terms of any questions, would you prefer them to be taken at the end or during the presentation?
Probably better going at the end, because we'll move on to once I'm complete. Ryan will do it on the civil side. Can answer questions on both at the end.
Yeah, no problem at all. So in terms of online, if anybody's got any questions, if you could just stick them into the chat and the guys will field them at the end. And I can see the recording started, so thanks for doing that, Isaiah. So this whenever you're ready, guys.
Thanks very much, David. As David said, my name's Conor Fitzpatrick. I was a senior project engineer at the Belfast Grand Central from at the end of 2023 through delivery and planning through to completion, and then doing a bit of the CRE role on the closeout. I'm going to run through the permanent way specifically, and then my colleague Ryan McCoy, he'll come on and do his part on more of the civils aspects of the job. So just a quick overview of the schedule, the slides. Kick things off, just going back to the early stages, the timeline back when we first started to detail delivery, coming through to the actual production timeline up to completion. A quick site overview to help get you up to speed on whereabouts the project is, and then moving into run through the delivery stages, and then delve into some more the kind of detail with the Blyfield curve panel build. Talk about some of the plant that we made use of, and then finally we'll touch on the formation design, which is quite substantial, which then leads quite nicely into Ryan's talk where he talks some more on the formation. So early stages, advanced timeline, we go back to May 2018, developed a detailed PWI delivery strategy, which was integrated into the S&T programme, which had already commenced prior. That took us up to October 2020, collaboration with the main civils contractor, which was FSGV. They were obviously building the station and the platforms. And then September 2021 was the commencement of the enabling works. So more the delivery schedule, this is PWI specific. Early 2023 was the first of any advanced prep works. And then breaking ground essentially in August 2023, which was the non-operational site, so within the new platforms, and working our way out to the existing boundary fence. Moving up to April 2024, where the first disruptive blockade, a small blockade, which was allowed as almost a trial run before the big blockade there, May to August 2024, which was a 13-week blockade. Split into two parts, which I'll touch on. One part we did reduced possession, and then the second part was completely line block. into Belfast City Centre. And then the autumn of 2024 was the commissioning period. So moving on, thought I'd just touch on the old Great Victoria Street station, which was the replacement, Belfast Grand Central's replacement. You can see there just in the picture 4 platforms, curved platforms, which, you know, with maintenance, platform clearances, etc. And it was jointed track. So Translink really wanted an increased number of platforms to allow for the frequency of the Dublin lines that was due to be increased. So they took that up to 8, and one of the big ones was straight platforms, just to reduce the maintenance. So moving forward, just in a site overview, we split the job into a number of stages, really dependent on the windows for the blockades or the windows of the opportunity of work that we could do. You can see in the top right there is the new platforms, which we referenced as the brownfield site, which all the work was carried out prior to taking any blockades. The rest of the stages you can see there are split up dependent on the area of the job. And then with three compounds servicing it. So the East Ramp compound, which was initially sandwiched between the old station and the new station. And then with the BMX compound at the top of the Dublin lines there, which was again was sandwiched between the station and the Westlink Junction motorway. So tight areas to work within, with a small compound at Weaver's compound, you can see there, but that was for rail only. Now, I'll touch on it later, but you can see the compounds are really servicing one area of the job. Your likes of your stages N and O, the red and pink, do not have direct access, which was one of the challenges. So kicking things off, we took over the brownfield site basically from SFGV. So within this area, they were actually contracted for the formation build-up up to ballast level and any associated drainage that you'll see there on the left-hand side. And then we were to come in there and build the ballast and the track components on top of that. So now I got a picture there looking out from the station. So we start to progress on the platforms. So this work's completed between August and December 2023. Whilst the old station was still fully operational, you can see trains there at the top of the picture still running in and out. The brownfield work allowed us to remove substantial work from the main summer blockade, easing pressure on that delivery and reducing disruption to the public overall. It's worth noting at this point, huge integration with the main contractor. Obviously, if we were looking to work within platforms 2 and 3 lane track, they were unable to work on the 2 platforms. So substantial integration day to day on this. This is the picture, you've turned round now, the build's progressing from the station outwards under the busway bridge there. You can see on the right hand side the station, and then there in the centre is what we're referring to as the East Ramp compound. So tight access road to manage, and not a lot of room when you're servicing the full works there on the left hand side from the platforms out. So again, just showing you the tight access points that we had. And then it was, we've just, for reference, we've swiveled 180 degrees. So we're now looking from the station outwards. So the brownfield site was basically, the key objective was to build as far out to the existing boundary fence as we can. So you can see there, we're actually half built units S and C prior to getting access to the railway. And then on the top of the picture there between the train and the road, Ryan will touch on it later, but you can see there's actually an area of the concrete foundation slab already poured as well, which Ryan will touch on. So that then took us into the Easter blockade. That was the first disruptive works. Basically a length of 170 metres of plain line with formation works on the up Dublin and another 185 on the down. The key point to this was installation of 778 points, which was the commencement of the new line. So the existing infrastructure Dublin lines only had 2, the up and down Dublin. This was now to facilitate trains in and out of platforms 7 and 8 in the new Belfast Grand Central. So just as it says there, this gave us, it was only a 29-hour possession. It gave us an opportunity to carry out some time motion surveys in preparation for summer and assess the effectiveness of compounds that we're using. So that took us into the summer blockade, 13 weeks in total. Part 1, we still had the central lines open, so still had to facilitate the Dublin Enterprise service, which was travelling into Lanyon Station. Key objective was to tie the new Dublin and Blyfield lines to the track constructed prior. So we've built out as far as we could. This was now about tying in the new lines into the new station. Upon mobilising, the existing railway boundary fence was removed and the track lifted out. So I just thought I'd show reference to that there. Top left was the old lines into the old GBS, which we then removed. And you can see the east compound on the left-hand side, which eventually gave us scope to increase our compound out into this area. As I mentioned, it allowed for the Dublin, so I've just put a photo there of the physical barrier for the work site. So again, Ryan will touch on it, but I thought it was pretty important for me to mention it with regards to the programme for our work. So a huge part of the summer blockade was the completion of the foundation slab, which formed part of the formation detail. The installation of the slab was a critical activity in the deliver of the summer blockade. Any delays to it would have pushed back the subsequent installation of the track above. So we built in some time and err on the side of caution within the programme, but that was always a risk if that overran, that it was going to push back the construction of the track above. And I've just put a note there. You can see essentially cut off the brownfield site from the works at the top of the picture. So we had to build in an access road there on the left-hand side just to connect the two. Carrying on the summer blockade part 1, what we were calling stage M, that was the Dublin lines. So stage involved the following works. So formation build up across 3 lines. You can see in the picture different crossfalls to each cess with a build up of 6F, type 1, different layers of terram, etc., which I'll go into in more detail in the formation build up. Transitions between the formation, those in the bottom ballast levels, and then in this part, this stage, it was 800 metres of plain line and the installation of a crossover. Then just a note on the challenges of this one. The BMX compound that referred to was actually in the middle of the job, so you couldn't work the conventional renewal type that it would, when possible, when working from one end to the other, removing everything in the one direction. So essentially, we had to work from both directions, and when during the formation build up, we're having to dig ourselves out into this compound and work our way out. And then this just gives you an overview of that. So you've got the 3 Dublin lines there, and you've got the BMX compound on the right-hand side. So you can see our access was actually coming onto the middle of the job. You can see at the top the 779 crossover mid-installation, and that's the 3 lines that would then go down and service the new station. And just some more photos, just kind of to give you an oversight, right up from ballast compaction there across the 3 lines up to some post-tamp photos there looking back towards Dublin. So continuation of part 1, moved into stages P and Q, which was the Blyfield lines. Methodology a little different, involved the same formation build-ups and those in bottom ballast levels. Also the introduction of some drainage, which we installed in the 6 foot, which was good. So it allows us, while we're building the formation, to build the drainage at the same time for kind of optimal production. And then at the bottom there, we installed 45 number pre-curved and pre-built timber panels. So very tight radius in here, between anywhere from about 184 up to 250 metre radius. These were installed using the McCoy panel lifters, and I'll go into a wee bit more of the engineering on the panel build later on. Just some more photos there, give you an idea. So on the left, that's us excavating the full Blyfield curve. And then to the right hand side, we've started to build up the layers of the formation. We've installed the 6 foot drainage, beginning to compact it. And then just a kind of post install of all the curved panels. So you can see that that's pre-tamp. So the building the panels beforehand with the pre-curved rail really made a difference to the quality of the install that we were able to provide the Translink. That took us on to what I refer to as closing the gap. So at the start of June, Blyfield and the Dublins had been installed as far as possible, with the foundation slab now complete. Process of joining the new lines into the station could commence. So this involves stoning up the entirety of the foundation slab footprint, installing 7-point ends, including a double crossover, associated plain line, and 100 metres of cess drainage. You can see just another photo. To the top of the picture is a brownfield site, so you're now working out. We've now got the third line on the left-hand side emerging, double crossover being installed with the two nearest switches, the alpha side 782 and 783 going in using McCullochs. You see here another 3 photos that are progressing further. So we're now looking out at Dublin's, just going from right to left, compaction at the bottom ballast, and then in the middle, the associated plain line being installed, joining that up. And then on the far left, we're now beginning to join in the Blyfield lines. Which led into the kind of final product for the end of part 1 looking like that. So we've now got access from the Blyfield lines on the top left, the 3 Dublin lines now all going into all 8 platforms of the new central station. And probably at this point, that was the end of the 13 weeks, a huge milestone in the project to have the new infrastructure connected into the existing. That leads us then into part 2, which, as I mentioned earlier, was then full line blockage. So the 2 central lines being blocked, the Dublin Enterprise could no longer come into Lanyon Place with burst replacements instead. But main works in the central reverse was a reconfiguration from 2 lines down to 1. Now with the main station at Belfast Grand Central, there wasn't the need for 2 lines on this central reverse, and it would only be used sparingly when required. So dropped it down to 1 line. Again, formation build up, new cess drainage, and new plain line jointed track. You can see in the picture on the right, we left the existing track in and left for as long as possible until the intersection point with the new single line alignment. That allowed us to stockpile sleepers as far down as possible, and then we could run the remaining ones with the sleeper beam where we didn't have any service road, which you'll see in the next couple of photos. So left-hand side is the formation build-up with as far as we could go with existing tracks. So essentially there where the track started to come over is the new single line alignment where it crosses over into what would have been the old track. And then a picture on the right, as I said, where the sleepers were laid out using McCullers. And then again, some final photos. So that's looking back up towards Dublin, post-camp. We now have obviously only 1 line, and we've got the cess drainage all the way up the left-hand side. And the far photo on the right is now coming down into the next stage, which I'll go on to next, which takes you down towards City Hospital and towards Lanyon Place. So part 2 still, this was the last stage, the blockade works, and it was up down central. So this ties into the central reverse. So again, reconfiguration of the track layout. Obviously we're only tying into a single line now, so S&C had to be rearranged. Again, formation build up 6F type 1 at Terram, those in the bottom ballast levels, and installation of a turnout and another crossover. Again, more just construction photos to give you an idea. The bottom ballast there on the left, the boys obviously laying sleepers there, and onto the right hand side, which was tying into the Blyfield lines, formation build up and drainage there. Which left the kind of final product, and on the left there's the crossover that's now tying in back towards Lanyon Place into existing infrastructure, and the photo on the right is now looking up the central reverse that I just spoke about. So at that point there, summer blockade, that was all the works complete, all the railway info essentially, and tied in. So after the delivery stages, I just want to dive into a couple of areas. Got the pre-curved panel build, as I've touched on earlier, the Blyfield lines. So the design was confirmed as to be jointed track construction with an accompanying check rail arrangement. Now, I suppose a number of factors obviously to consider for Babcock as a delivery contractor. Installation methodology, would we build it loose? or would we panelise the curve? And then following on from that, would we order a lot of pre-curved, pre-cut rails, cut to suit, rail lengths? That's consideration of the check rail arrangements and the check rail joints, and then also taking into account the design gauge variation. So due to the tight radius of the curve, the gauge actually went out from 1600 to 1606 and then back in. Taking into account adjustment switch locations within the curve, as well as IBJ types, locations, maintaining compliant rail lengths, and then also considering the different temperatures of construction in regards to joint gap regulation. So chosen methodology then went for us to panelise the layout. This involved ordering pre-curved rails and IBJs, and they end up the design with a mixture of predetermined rail lengths and cut to suits to allow for some constructability tolerances. We went back to first principles to establish leads and lags, but using CAD to design each panel and ensure accuracy when constructing. Created a panel schedule just to ensure correct order of construction and installation. And again, we made use of McCoy, just allowed us to install both roads at the same time, working back towards the compound. There's just a snippet, so that we ended up overlaying. You can see the small pink writing that's got labels of the panel numbers and where the joints fall. That was overlaid against the existing PWI design CAD file. And then from that, we were able to pull out panel diagrams. So see there, the panel involved the length of the rails, both inside and outside, sleeper spacings, the radius, what the gauge should be. Also the pink writing there on the left and at the end of the rail ends. That was how it came up from site to allow for from factory, sorry, to allow for easy identification on site. And these were given to a team that then worked on these off the critical path, building these in the compound. And then just some photos, just to show, I know it's shown it earlier, just some more photos and ones from above of the install of the panels. Moving on to some of the logistical challenges. The hub was always a challenge due to its location within the heart of Belfast city centre. So interfacing with the main works contractor within the station area was an ongoing challenge, as we would say. Limited suitable access points and restricted sites. Large volumes of material had to be brought in and removed through tight compound areas. So no access to engineering trains to be able to remove it directly from site like you would on the mainland at Carlisle. Everything had to come in and out of our compounds. And in turn, this reduced productivity rates due to the distance travelled from the actual worker site to the access point and backwards and forwards. So one of the solutions, we maximised the plant that was available to us over in NI to help combat some of the challenges. First ones was the 360-degree track dumpers. Due to access constraints, travelling over the formation could not be avoided in this project. Therefore, track dumpers were the perfect machine to protect the formation. Now, these dumpers are also capable of swiveling 360 degrees, meaning for the likes of that you can see on the right-hand side, they're able to drive up and drive back without turning or damaging the formation. So, moving on, we set up what was as close to an engineering train as we could using a Unimog complete with trailers. Helped massively during part 2 of the blockade that I touched on earlier, where there was limited access to the further away sites. Obviously the trailers there you can see, they were able to use them almost like side tippers, like your conventional side tipper engineering train on the mainland. And they could also stone up like almost like a mini oil ballaster as it travelled over site. So great help these were for blockade part 2. Also used GPS excavators, as I touched on, with limited space in compounds and large materials to remove. GPS excavators made this efficient as possible. Obviously, machine control files into them eliminated the chance of over digging or digging too wide. And we also created drainage excavation files, which increased the production of that as well. GPS allowed us to basically work, we were working on multiple fronts, allowed us free up engineering resource. They only required spot validation checks because they had the file in their machine. So moving on, the final thing I'm going to touch on, the formation design. It's quite substantial. You can see there after a snippet of the main throat area where you can see the different track formation solutions. Solution B, the top right, is the foundation slab, which Ryan will touch on. And then the other one that's not in sight is track solution E, but that was within the brownfield site that the main contractor produced. I'm going to focus in on the next slide just to give you an idea on the transition there between the pink and the green on the drawing, transition detail 2. So this was at chain age 180499, and this is solution A. So you can see different crossfall with over 2 roads going to both cesses and associated drainage. The minimum ballast depth of 300 mil and 250 mil at type 1. This had a separator both top and bottom of that type 1 with a geogrid layer in the middle of it. Moving on to the solution C, which was substantially deeper. The same configuration with type 1 in the layers, but another additional 450 mil cap layer, a 6F4, which again had another geogrid in it centrally. So a lot of layers to be building up with the access that we had, and a lot of layers to compact, which proved challenging. That was to give you an idea. And then just a mention on the transition detail between the two, which was quite complex. So there was a 10-metre transition essentially from solution A to solution C, 5-metre overlap into solution A, and then a 5-metre ramp down into the deeper formation treatment. So you can see there in detail B, you have this wasn't really practical to construct, and in the end we ended up, instead of having the 50 mil layer there from your separator to the first layer of geogrid and then another 50 mil to the geogrid, we put the first layer of geogrid directly on top of the separator layer and then kept the next layer 100 mil up to that. But you can see just the kind of the challenges with the different formation treatments that we had. I think for me, there's some metrics there. I'll run through it. It does cover civils as well, but just to give you an idea of the quantities that come in and out, you know what I mean? And then the old ballast clean recycled, which is a big thing for Babcock to recycle a lot of the ballast that was used. For me, I think I pass on to Ryan now, who's going to touch on more of the civils aspect you want in here.
Okay, so Ryan McCoy, and I have the pleasure of presenting to you today on Transport Hub and the civils elements. So to us, we call it the Belfast Transport Hub, but the station was known as Belfast Grand Central. The project is now nearing completion, and it's the largest integrated transport hub in the island of Ireland. The project is the largest, well, it's the largest railway interlocking constructed outside of London in the last 20 years also. So for me, I was the civils CRE at the end of the project and the temporary works coordinator. So I'll give you a bit of my insight to the project. So the project was first talked about in 2012 and is due to be completed later this year. The station is now operational. The old facilities in Belfast had been operational for the last 29 years and had basically remained unaltered from the day that they were installed. They were operating at full capacity and hence called for the improvements. The new Grand Central Station has 8 new railway platforms and 26 bus stands in a state-of-the-art building, catering now for 20 million passengers per year. The new station has increased capacity for up to 2,000 seats per hour for both rail and bus movements in and around the city and beyond. And the image to the top right of the slide shows some of the key companies that made this project a success. As can be seen in the slide, Grand Central Station is exceptionally close to Belfast City Centre and exceptionally close to Belfast City Hall. The project is strategically positioned between the 2 main universities in Northern Ireland and the 2 largest hospitals in Belfast. This presented its own challenges during the construction phase, as you can imagine. The middle picture on the slide, it shows the construction site during the enabling works. with the picture to the right showing the old station now demolished and the interim works to connect up the new station to where the old station used to cross over. The project was originally estimated to cost 175 million, and it is now expected to cost closer to 340 million. The Babcock contract was for 56 million and was completed under NEC option C. So moving on to the ancillary civils. To protect the programme and reduce the overall risk profile, the ancillary civils work was predominantly completed on T3 possessions, working rules of the route. So this is basically between the last train in the evening and the first train in the morning. Babcock managed and delivered these works for 18 months, maybe even slightly longer, prior to the station opening. Working alongside various subcontractors, we managed them to complete as much work as possible in advance of any bigger blockades. And basically this just was to protect the programme overall and ensure the successful delivery of the project. The project covered almost 7 miles of predominantly dual line track. It passed through 8 different stations, and it was crucial to consider other disciplines, possession arrangements, access for both plant and personnel, because they weren't the same. Working with various subcontractors on a daily basis, we conducted weekly meetings to track progress, programme, and review any on-site problems. Although these works were predominantly completed on night shifts, where possible, civils would utilise other disciplines' blockades to complete more complex tasks. So, as the temporary works coordinator, I was responsible for managing temporary works on behalf of our subcontractors. The design on the slide is that of a UTX, which is an under-track crossing for those that don't know. And basically, we had this design. We had it designed by our temporary works designer, approved by TransLink, and then the picture in the middle of the slide shows how we implemented it on site. And this basically is the safe methodology of what we do. The picture there in the bottom right of the screen, to most, is a railway line with a wee bridge in the distance. Although for a civils man, nobody looks at the troughing on your left-hand side and the drainage as well. You obviously look at the points and all your fabulous stuff there that goes on that Connor has explained. But without the civils elements, it wouldn't be the railway wouldn't have its intricacies as it is. So moving on then to the foundation slab that Connor's already touched on. So the railway corridor was widened on the approach to the new station. It would now pass over a section of land which contained Belfast Sleech. So Belfast Sleech, well, what is it? It's a mixture of estuarine clays, silts and peat. Its exact characteristics vary drastically and present very difficult building conditions. It's considered one of the most problematic soils in the UK, and in Belfast it can be at depths of up to 8.5 metres. Therefore, with the expected volumes of traffic on the approach to the new station, the solution needed to be one that would not require a large amount of maintenance in the years to come. Therefore, a concrete reinforced slab of depths up to 700 mil would be required, and the slab itself consisted of over 1,000 cube of concrete. As shown in the design drawing, this slab will be poured below the bottom ballast, so it's not known as a track slab, which some others would know traditionally. When Babcock was presented the design, TransLink had already engaged and looked at the constructability of the slab. The design to the right-hand side of the slide shows a sheet piling design, which was to enable us to construct the third line area. This consisted of 12 and 14 metre long sheet piles installed at approximately 1.5 metres from the nearest rail. So, once I'd reviewed the design, I engaged with various special subcontractors to pull together suitable solutions to complete the work. However, due to the work being sandwiched between an operational busway and an operational railway line, the prices received back were excessive. The image to the top right of the slide shows a drawing that I produced to basically ensure that the piling rigs required would fit on site. Space was precious, and only a piling rig with an articulated boom could be used. From the onset, I always thought if we could remove the need for sheet piling completely, this would be the easiest method of construction. I explored constructing the entire slab during a large blockade, although as you would expect, we didn't have the time for this. This didn't work as the sequencing of the P-way also didn't align. So due to the substantial cost of the piling works themselves, I started to think of more alternative solutions to construct the slab and still have safety behind, to allow the operational railway to run. A key driver was being able to construct as much of the slab offline during the day and to avoid rules of the work, which is basically nighttime working, as this would put the cost of construction and the duration up exponentially. This made me consider other forms of retention to facilitate daytime working, and through various iterations, we presented the photo to the bottom right, which is a legato block wall system, to the client. Instead of installing sheet piles adjacent to the track, we suggested building this legato block wall. Consulting with the temporary works designer, we refined my initial ideas, and as shown on the slide, the wall would sit within the track support zone, which is this purple line shown on the slide. For those that don't know, the track support zone is the area beneath the railway line that is necessary to maintain its integrity. Therefore, when working within the track support zone, there's increased control measures that need to be adhered to. So combining this with the uncertainty of the Belfast Sleeps project or the properties meant that this wasn't going to be a feasible option. Unfortunately, we couldn't move the legato wall out any further to get it outside the track support zone, as it would then encroach on the track slab itself. Determined to come up with a viable solution to construct the slab, we started to look at the sequencing and phasing of the slab itself. To mitigate against the expensive sheet piling meant that the slab would need to be constructed within a blockade or a series of blockades. The design to the bottom left of the screen shows how I split the slab into 3 separate sections. Note that the track side, the blockade element there denoted in red, is running into the old station, so we couldn't just go ahead and continue to build over the top of this at that stage. This was a successful turning point for the construction of the slab though. I worked alongside a piling subcontractor, and I pulled together a plan to construct the 40-metre section, the finger section, in a condensed and realistic programme. The solution was to construct this area at Christmas time. This meant that during the blockade, the excavation, blinding and construction works would all need to take place. The excavation works would be constructed with a suitable angle of repose. Basically, there would be no temporary works. Subsequently, this meant that the adjacent track and sleepers would become temporarily unsupported. This would only work when there was no trains, and hence we needed to do it within a blockade. So the civils work would continue as planned. Upon completion of the civils work, there was 2 days allocated within the blockade to backfill over the slab and reinstate the ballast accordingly. Tamping was completed and the track slab was handed back with the initial 40 metres all poured. The blockade was very short duration and required some swift construction methods. So in the lead up to the blockade, the subcontractor prefabricated the steel reinforcement, which is shown there in the bottom left, to ease the speed of setting the reinforcement in during the time. Another innovative idea was the use of permaform, which is a permanent formwork. This meant that there was no time lost within the blockade stripping and moving shutters. It also meant that 80% of the backfill around the slab itself was done prior to pouring the concrete, and this reduced our time reduced our workload during the blockade. And then finally, the use of admixtures, the curing time of the concrete, to aid the curing time of the concrete, to allow for backfilling over the top of the slab to reinstate the track support zone and the ballast shoulder. Also shown there in the middle photo is a concrete pump, and the adjacent lines are closed within the blockade, but they're open to us working. And this sort of machine couldn't have been used within rules of the work route possessions due to the collapse radius of the machine itself. Given the large area of the network that was also closed down at Christmas, we then took advantage to complete works on a nearby platform. So that's the 3 photos on the right-hand side of the slide. During the blockade was the ideal time to work through the platform, as there was no interface to be managed with the public. It removed the need and the risk to complete the works piecemeal on night shifts, and overall was more productive. As shown in the photo, there's a large volume of new and old services which all had to be incorporated into the new system. And completing this work piecemeal would have been very difficult to overcome any complexities. So moving on to the brownfield element. So following the Christmas blockade, works on the slab continued, constructing as large a section as possible offline before completing the remainder of the works in the summer blockade when the old station was actually closed down. I maximised the area of the brownfield slab by implementing a CSE environment. Ultimately, this makes the area into a high street environment. This removes a lot of the restrictions set by working on or near the operational railway line, allowing the construction of the brownfield slab to take place on day shifts adjacent to the railway line with some additional control measures in place to ensure compliance and health and safety. Ethically, with the position of the job right in the centre of Belfast, this was the right thing to do for both the people in the nearby area and the construction workers. The picture to the bottom left of the screen shows the CSE barrier and fencing installed, with the picture above showing an aerial photo of how the area of poured slab was maximised on the non-track side of the CSE barrier. During the planning stage, I had the location of the construction joints moved to accommodate the CSE barrier, and the aerial photo shows the sawtooth arrangement of how the joints were positioned. I supplemented this with the use of Ancon rebar couplers to remove the need for long lap lengths between the different pours to maximise the amount that could be constructed offline. As the temporary works coordinator for this project, part of my role was ensuring temporary works for cranes and platform designs. I worked alongside my PWI colleagues to allow for cranes to be set up on top of the reinforced concrete slab, and this facilitated the building of S&C units. These units allow the cranes to cross over between different railway lines. Liaising with the slab permanent works designer, the temporary works designer, we collectively produced a design and suitable platform for a crane to sit on. On site, we ensured that the crane was suitably positioned, whilst confirming that the concrete had achieved an adequate strength. And the photos to the right-hand side of the slide show how we done this. So moving on to what I called the bottleneck. The phasing and management of these works was no easy task, whilst trying to programme the delivery of the slab around the ancillary civils work, the drainage work, and whilst PWI pushed on with their construction build of the slab, or of the track build, sorry. In addition to ensuring that E&P and S&T colleagues could have access to get to their elements of work also. The sketch at the top of the slide shows the green area. The green area now complete, with the red area remaining. Civils couldn't complete any more work until the old station was closed down. With a large element of persuasion, Translink granted Babcock a 13-week blockade to close down the old station and link up the new railway line. A 13-week blockade is virtually unheard of on the network. However, given the complex nature of the project and meeting at this bottleneck, it was necessary to deliver this project. This was the largest blockade completed in Ireland and consisted of a 13-week blockade over a 91-day period, 280 shifts, and over 100,000 man-hours. The pictures on the slide show some of the construction work that took place during the trackside element on the approach to the new station. And it shows the intersection of the Bangor line, the Portadown Newry line, and the adjacent Dublin line. Due to the available space on site at this pinch point, the first 5 weeks of the 13-week blockade was predominantly for civils to deliver the remaining element of this foundation slab. I was responsible for ensuring that these works were delivered and managed effectively throughout. As a delay at this first phase of the blockade would have a knock-on effect to every other discipline. The unfortunate part for me is that all my hard work, planning and managing of this foundation slab from the design stage right through to delivery will remain largely unseen by those who have benefited from the new infrastructure itself. However, without such a structure and constructed in the manner that it was, the project would not be in the position that it is today, a flagship project. So to conclude, a major milestone for me and a large number of the BTH staff was completing this project alongside the NIROC project. NIROC, which is the Northern Ireland Railways Operating Centre, this project was to modernise 3 separate signalling control points and rationalise them into one operational facility. The civil scope included 400 metres of cable route, both surface and buried. FSP foundations, the creation of a new PSP and compound, and associated route works. The new facility was programmed and constructed in line with the BTH project, as NIROC had overall control. And this completes my presentation. Thank you for listening.
Thank you, guys. Have we got any questions in the room? You guys?
I'd just like to say, boys, that was a tremendous presentation, well presented, and can I specifically highlight how good the photographs were. Just it gives you such a clear picture of how you constructed everything. Brilliant, absolutely brilliant.
Yeah. I'll kick off the questions. Looked like it was a very well executed project, but was there anything with the benefit of hindsight that you would have done differently? Right, within either discipline?
I think that right.
Where do you start?
What was that? When we asked the PWI to stop the recording and then just talk about stuff rather than
Yeah, that's fine.
the recording on the PWI website. Any?
Yeah. Would that be okay to stop the recording, please? Isaiah, if you're still there.
So often they aren't.
Can I do it remotely?
I think so.
Right, okay.
I think just let it go until it's closed.
Yeah.
It's not an issue. I was just trying to think then. Particular, no?
No.
Off the top of my head.
The panelists that you used, were they the bigger ones at McCulloch's done? Because I know they're not approved for use in the UK yet, which is a bit annoying. Because they look like a good bit of kit.
It's that I thought they were the only used for the switches. On that, are you referring to the ones that can lift the crossing units as well?
Right, because
I don't think they're approved yet.
no.
No, so that was they've been approved for a while. It was just the smaller ones, just for the switch panels. There was discussion around that might potentially get to use them, but they weren't ready at the time.
I was going to ask, where was S&C manufactured in the pre-curved panels?
So the S&C was all Progress,
Okay.
and then came over Progress. The pre-curved panels we done in-house. So essentially we designed the panels and then we built them in the East Ramp compound during the works. So I assigned a team off Critical Path, started building them through the summer blockade part one. Obviously working from the ones we needed first.
Right.
And then when it came the time installation, we could start running them in.
Right. So is that a low loader through the ferry on the ferry?
For the S&C?
S&C?
Yes.
Got a couple of questions online. Tom Wilson said that the build strategy for the Blythefield lines was pre-curved panels making use of the benefits provided by pre-build. However, one of the pictures showed a fairly large S&C unit with bearers laid awaiting installation of steelwork. Was the method for installing this S&C unit forced or favoured over a panel installation, and was setting out of the bearer positions time consuming?
So that's probably just a bit confusing, the pictures. There was no S&C within the Blythefield curve. So essentially from the backs of the S&C, what's that?
In the junction just as you come off the Blythefield.
Is it referring? Just
Yeah, I think
at the
so.
top end or the bottom end?
Bottom end, I think.
Bottom end. Well, essentially our panels went to the backs of S&C.
Yeah.
So S&C was built kind of traditionally, switch panels, closure panels, and then they got spoutless. The panels started from the backs of 790 turnout and the back of on the street at the crossover.
Right.
So that helps the question.
This may be part civils, part PWA, but again from Tom, how was the transition in stiffness between the support slab and non-slab areas designed and then constructed on the site?
Well, obviously we were a designer on that, but the detail and the transition was implemented on site. So going from your traditional formation build-up into the slab, there was a transition detail. They never shown a picture on that.
Also done it at the steps as well.
Yeah, so
depending on the what you wear.
from the side and rolling into it, there was transition detail from the designer. Designer was firmly doing this, but I've just never shown the transition detail on it. But there was an overlap of material that went down to the slab and terram that went under, so there was a transition on it.
I was keen to know if the slab was stepped or whether you stepped the subgrade. Sounds like you reinforced the soil.
What was that, sorry, Tom?
It sounds like you had a reinforced soil rather than a stepped slab.
That'd be
Yeah,
correct.
that'd be correct, yeah.
The ramp and the formation is it that? That's correct.
In some of the wider sections, like the 3-track section, where you had the S&C, did you manage to keep a constant crossflow under the crossovers and turnouts without having the really deep drainage? Or was the drainage already there, or did you put in?
There was different, so some drainage was carried out the third line and the station route.
I wouldn't say it was exceptionally deep, though.
No.
No, a lot was quite shallow actually.
Right, okay.
The deeper stuff was on the old station side. No,
The right feels up around that area.
But experience in the past, when you've got big units, sometimes you end up by having a steady crossflow.
I said
You end up
going into the
really
drainage.
Aye.
Only is the track stab mitigated that because you were quite shallow in around that area as well. Then you're on a fairly flat plane as well, so we know you're not trying to transition all up between different levels.
Oh, yeah. Any other questions in the room or online? The guys?
Just type the name.
Okay.
I'll post a random question, probably more civils based, but what sort of sustainability stuff did you consider? A heck of a lot of concrete by the sounds of it. Was there any sort of considerations used to reduce carbon or anything like that? I assume some of the equipment or plant that was used could have been maybe powered alternatively using sort of maybe electrical power equipment and things like that. Was anything like that considered? It wasn't really discussed at all.
Not for the actual slab build itself.
You can't really get away from it.
No, see for that slab and the size that it was, and the other thing too was your time constraints. You just needed available machines to get in and get the work done, and that, you know, Connor touched on it and I said about it too. That first 5 weeks took a lot of convincing to get the client to believe we could deliver in that time.
Right. The only was the sustainability was we made an effort with PMA materials to get recycled. So I mentioned there was 18,000 tonne of ballast went out and got cleaned. We reused. A lot of the old timber bearers have went down to the heritage railway.
Yeah.
So made a kind of a point on that. But I noticed the it looked like the prefabbed rail sections. Were they timber sleepers that were utilised in that rather than concrete?
Yes, so that was timber in there.
And what's
Timber.
what drove that? No, 100% on the design. It was just that
Timber specified.
timbers were specified. Obviously, tight radius, curve. Probably the volume of traffic as well. Not substantial down that live field curve. Not 100% on what the massive factor was, but that was
During the early part of it, the ECI, we had proposed an alternative composite, but they weren't approved for use, so they were unable to adopt that.
Yeah, I know Scotland's utilised some like plastic recycled stuff, but I'm not sure how widely used that is.
Well, they're approved now, so they will be used now. But at the time that this was being initiated, the early contractor involved.
We're specifying the 1.9 jobs.
They're widely used down in the Republic as well now. They're really behind using them, so it's just not filtered up yet. But then if you've got a short time frame and just need to get stuff done, you're sometimes hands are tied.
Well, I suppose back to your initial question, the removal of all that sheet piling, because that was going to be permanent.
Yeah.
You know, you had tons of sheet metal that was going to be temporary to install the works, but was going to remain permanent. It was going to have to be left, and you're also going to have to, the install of them was going to be expensive, but it was also machines required. Then you're going to have to bring in cranes to remove them all again.
Yeah.
There was massive amount of temporary works required to install them, to then remove them again, and that was why the sheet piling methodology didn't work for us.
Yeah.
You know, I appreciate explained how we explored the legato system, but we did look at other alternatives.
Yeah.
We just wanted to remove all temporary works to get that. There's only a 40-metre section, granted over the 150 metres of slab, but we just wanted
Yeah,
You're talking £1 million wasn't going anywhere.
yeah. I know, just buried and forgotten about.
100%. Same as the rest of the slab.
I can cry. I know it's a hard question to answer. I know it is, but like the railway's a traditional asset, and you're tied to traditional materials a lot of the time. So
Jordan, I think you asked a similar question. Hopefully you could hear what the guys were saying, that it was indeed timbers that were used along with the concretes. Tom's asked another question. Did lots of new track drainage installed? Did any of this require attenuation, or did it all tie into existing track drainage or outfalls?
well, there was some changes. I don't know if you want to touch on the area down at City Hospital, tying into that existing outlet, which came out.
Well, we did tie into the existing drainage at City Hospital, but we also diverted the flow around the Blyfields. What came around the centrals was then split, and the flow came around the Blyfields, which we changed ourselves halfway through. So Milky was big asset changing that.
Yeah, that's right. I mean, the PWI drainage design by Arup tied into existing outfalls throughout, but during construction we had some issues at City Junction. We had to do that diversion from run 16 away from the upsace of City Junction. We diverted that into the wideway and down through the Blyfields, just to remove the water intake through that reduced section through the bridge. We did have a section where we got to install the drainage and through the 5 foot under the down central line to tie into the existing drainage system at City Hospital. So that was a drainage design that was effectively signed off by the designer and the client.
We effectively diverted the flows in the opposite direction. That was because of an embankment and cables that were in the cess that we couldn't manage and disconnect at the time.
Another question for Tom. On the pre-curved panels under the check rails, was the gauge weighted and constant or variable? And if variable, how were specific panels identified to avoid installation error?
So the gauge varied from 1600 to 1603, and then a gauge from 1603 to 1606. So the areas that it varied and changed was identified in the offices, the same panels, so they weren't six. So that was identified as part of the adjustment switch locations, the IBJs. They were all taken into account when building the panels.
Right, got you. When it came to the pre-curved panels, did you use any coordinates to check that you were in the right place in terms of laying the?
So that they were all set out, with the Trimble, as you would for setting out a switch panel. Every one of them had a league and lag chainage as well for the tote station. That was how we landed them. So we put our Trimble onto the rail edge of the end of the rail to ensure it was within top.
Get a bit of confidence.
So that as every panel went down, we landed it as you would a switch panel.
Any other questions, guys?
Sneaky one for me, if you'll let me do a vocal one.
Go for it.
Again, on those pre-curved check wheel panels, you obviously left the check wheels out until after tamping. Sensible move. How many tamps did you give it before you put the check wheels in?
I think they went in post tamp.
Yeah.
So we'd go in post tamp, but it's always a difficult one. At what stage do you declare it? Not going to move again. I'm now ready not to tamp it ever again, ever again. And if I don't need to check the wheel out, I can put the check wheels in.
That was falling the tamp.
Falling tamp, yeah.
Just one time.
That was how many passes
Tamp twice.
Right. And then you decide.
Yeah.
Cool.
Yeah, so I got a rough tamp and a fine line then. Okay.
Yes, correct.
Okay,
But
it's all
also
to do with
the-
the consolidation, isn't it?
Yeah.
If you got that primary consolidation and you're laying to plus nothing minus 10, then a couple of tamps is enough. I'm just curious, that was all.
Did it also have the lateral resistance?
Only basically in the run on and run off of the curve. Just a couple of sections.
expensive things. Did they work?
City Junction and the lamps at the top
Top
end,
end, yeah.
Western Junction.
Long exercise in the middle where we had the whole way.
Final call for any additional questions?
I think just to echo what some of the chaps have said previously, fantastically delivered multidisciplinary project, guys. You can all be very proud of your efforts, I can assure you.
Yeah,
I've
absolutely.
had first-hand experience on it for a number of months.
Yeah. I was aware of this.
Well done.
I was aware of this project taking place, but I really didn't appreciate quite how big it was, particularly with the amount of track work out with the station as well, with this sort of triangle, you know, all the work going on that. It's really impressive presentation, guys, and I think you've done a really good job of showing how well it's planned and executed. So thank you very much for that.
Cheers, thanks for having us.
Aye. Just give the guys a wee round of applause. And thank you everybody who joined online and added questions as well. Appreciate it. So we'll just check it. Here's over there. It might just be a appreciation.
Yeah.
That's my question. Get away here.
He's going to drop it off.
Hang up. Oh, dear me. Good message. No more.
Maybe just click into it and it's just sitting there typing this.
Thanks.
Oh, there you go.
There you go.
Thank you guys.
Yeah.
You were about to hang up as well, Bill?
Yeah, I'm happy.